Let's go ahead and do a little bit more with exponents. So think about the volume of a cube, whose side lengths are x squared. Some value squared is the measure of each side. Well, the volume would be each side raised to the third power. So let's use the definition of our exponents to kind of expand and simplify this expression. So first let's deal with the fact that we have something raised to the third power. So we're going to have something times itself 3 times. X squared times x squared times x squared. And we can expand that even more as x squared twice, or x times x, and x times x, and x times x again. So we have an x squared, another x squared, and another x squared. We have 6 x's total, giving us x to the 6th power. We can apply that logic with the same thing for our power rule, which is 2 times 3. We multiply the exponents together, and we get x to the 6th power. We see that power rule here. We multiply. If we have an integer coefficient, then that integer coefficient also gets that exponent, or that real number coefficient. It doesn't have to be an integer. When we are multiplying two things together, and we have that same exponent, we also have we can apply that exponent to both of those. And the power of a quotient rule says the same thing. If we're dividing two things, that exponent applies to both the numerator and the denominator. So let's go ahead and simplify some expressions. X to the 5th to the 7th power is the same as x to the 5 times 7, which is x to the 35th. Next we have 2 to the 2 times 3, which is 2 to the 6th. We can actually simplify that as 64. 5 to the negative 1 times 2, 5 to the negative 2, 1 over 5 squared, 1 over 25. Y to the negative 3 times negative 4, y to the 12th. Now we can use our power of a product and power of a quotient. So when we apply this, if it doesn't have an exponent, we assume the exponent is 1. So we're essentially applying the same rule to all factors within. So we have 5 to the 3rd, x to the 6th, 125x to the 6th. 2 to the 3rd, 3 to the 3rd, gives us 8 over 27. 3 squared, p to the 4 times 2, q to the 5 times 2, 9, p to the 6th, or sorry, p to the 8th over q to the 10th. Our base is 2, negative 3 times negative 2, over y to the negative 2, equals 2 to the 6th over y to the negative 2, 64 y squared. X to the negative 5 times 7, y to the 2 times 7, z to the negative 1 times 7, x to the negative 35, y to the 14th, z to the negative 7th, y to the 14th over x to the 35, z to the 7th. Now let's mix all these properties together in order to solve. Let's start by applying our power rule. Keep in mind that we have x to the 0 power. Factor is going to end up going away, but we can go ahead and work through it. 2 has a 1 exponent, 1 times negative 2. 0 times negative 2. Negative 3 times negative 2. 2 to the negative 2, x to the 0, y to the 6th. X to the 0 equals 1. so we don't need that. And we get 1 over 2 squared times y to the 6th, y to the 6 over 4. Now we could apply either our quotient rule first, or we could apply our power rule first. Either one would be fine. Let's go ahead and do it both ways. So we could go ahead and take x to the negative 5th and subtract negative 2, which gives us x to the negative 3. Then we apply our power rule. X to the negative 3 times negative 3 gives us x to the 9th. Or if we wanted to apply our power rule first, we could have x to the negative 5 times negative 3 over x to the negative 2 times negative 3, x to the 15th over x to the 6th, and then our quotient rule still gives us x to the 9th. So you see there can be some variations in the orders. As long as you are appropriately applying the rules, then you should get the same result. A little trick that we can do when we have the negative exponents is remember that the negative exponent makes it the reciprocal. Well, the reciprocal of 2/7 is 7 over 2. So we can apply the negative exponent rule to go ahead and get rid of that reciprocal, and then our power rule, 7 squared over 2 squared is 49 over 4. Here we got a bunch of rules. Let's go ahead and simplify some of these first. We'll keep 5 to the negative 2 for now. And we can go ahead and simplify x to the negative 5 and y to the 16th. That gives us 1 over 5 squared, 1 over x to the 5th, and y to the 16th. So we have y to the 16th over 25x to the 5th. I recommend usually kind of simplifying inside before applying the power rule, but the choice is up to you. If you'd like to do it in a different order, go ahead and pause and then check your answer to mine. 3x squared y to the 1 minus negative 9 over z. Z is still in our denominator. So we have 3x squared y to the 10th over z. Before we apply the power rule, let's do the negative rule. The negative exponent is going to give us our reciprocal. Our reciprocal is now going to be z over 3x squared y to the 10th. But instead of the negative second power, now it's positive. And then we can apply our power rule. Squared, 3 squared, x to the 2 times 2, and y to the 10 times 2. Squared over 9, x to the 4th, y to the 20th. We'll take care of each fraction before we move to the next. Here we've got a power rule. 3 to the 3rd, a to the 6th, 2 to the 3rd, x to the negative 3rd, times x to the 3rd, 4 to the negative 1st, a to the 2nd. We can now just treat this as one big fraction, since we're multiplying numerator times numerator, denominator times denominator. So we have 27 a to the 6th minus 2. That took that and applied our quotient rule. We have x to the 3 minus negative 3. I took that and applied our quotient rule. We also have 8 in the denominator, and then 4 to the negative 1 moves it up to the numerator. So we can go ahead and simplify a little bit more. 4 over 8 reduces, so we have 27 over 2, a to the 4th, x to the 6th. This leaves us with 27, a to the 4th, x to the 6th over 2. Let's go ahead and apply our power rule. B out of 6, 2 squared, b, x to the 2b. Then we can apply our product rule, x to the negative b plus 2b, and 2 squared is 4. We can combine like terms, we get x to the b. Power rule. And then that gives us y to the 18a over y to the a minus 6. Quotient rule. Y to the 18th minus a plus 6, 18a. So y to y to the 6a over a y to the a minus 6. Use our quotient rule. Distribute the negative. And we end up with y to the 5a plus